All right, so today we're going to talk about 9-3 radical expressions. Now we're going to look at what is the equivalent expression for the following. Number 1, we have the square root of 63. Now, I'm also going to call it either the square root of 63 or radical 63. So when we have something surrounded by the square root, it could also be called a radical. In order to simplify this, and we're going to find an equivalent expression from this, we need to break down into factors, which is called factorization. Using as many perfect squares as possible. Now we should remember what perfect squares are because I made you guys write a chart of those. So if I have a little slide note of perfect squares, we know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. I also had you guys write down 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. All right, so if we look back at the square root of 63, we want to factor that into as many perfect squares as we can. So if we break this down, we're going to look at 2 factors of 63 and hope that at least one of them are a perfect square. Well, I know 2 factors that make up 63 are going to be 9 and 7, because 9 times 7 is going to give me 63. Okay, so 9 is a perfect square. So when we find the square root, it's undoing something that's squared. So square root and the square of something are inverses. They're opposites. So the square root of 9, well, that's a perfect square. That becomes 3. So 3 gets rid of the radical. Well, radical 7, I can't break that down anymore. That has to stay under the radical. So our answer becomes 3 radical 7. Right, so number 2, we have radical 44. So we're going to try to break that down into 2 factors, and we want to make sure that at least one of them is perfect square. Well, 44, the factors that we can break that down into are 4 times 11. Well, the square root of 4, well, that can be simplified. 4 is a perfect square, so that becomes a 2. The 11 stays. I can't factor that down anymore. So our answer is 2 radical 11. All right, so number 3, we have 3 radical 27. So we're still going to factor inside the radical like we did numbers 1 and 2. The only difference is here I have a number outside of my radical. So just like when we have coefficients outside of our variables, and they don't have a sign in between, that means they're being multiplied. If I had, for instance, 2x, well, that means 2 times x. Here I have 3 radical 27, well, that means 3 times the square root of 27. So we're going to factor inside. So I get 27, well, what are two factors that make up 27, and I want one of them to be a perfect square? Well, that's going to give me radical 9 times radical 3. Well, we know that 9 is a perfect square, so that's going to reduce or simplify to 3, where this radical 3 I can't reduce anymore, so that stays on the inside. But we can't forget that I still have this 3 up top. So because that's being multiplied by my radical, this has to come down, and I have to multiply it times the 3 that I took out from the 9. So now I have 3 times 3, which is going to give me 9 radical 3. All right, number 4, we have 5 radical 48. So we're going to factor down 48 into two factors and make sure that one of them is a perfect square. So 48 can be factored down to radical 16 times radical 3. Well, now 16 is a perfect square, so the square root of 16 is going to be 4 radical 3. But now we can't forget that this 5 was in front of my radical, so I have to bring this down to multiply it by my 4. So 5 times 4 is going to give me 20 radical 3.